Hey y'all, it's me, Miss B. Today we are talking a little bit more about reference angles. We've already learned some, but now we're going to use them so we can evaluate trig functions more easily. Okay, so if we are able to use reference angles, then finding the values of the trig functions for quadrants 2 through 4 is a lot easier. I'm going to go ahead and label this first quadrant. So this quadrant 3 down here is negative, negative. I don't know why I started with that one. Sorry. This one's positive, positive. This one here is negative, positive. And this one here is positive, negative. And that's in reference to our x, y values. So over in here, our x values are negative, our y values are positive. Down here, both are negative. And down here, x is positive and y is negative. Okay, so this is pi over 3 right here, pi over 4, and pi over 6. And we know that because these are 60 degrees, 45 degrees, and 90 degrees. Or, I'm sorry, 30 degrees. Okay, so then, just like we learned in the unit circle video, this is radical 3 over 2, 1/2. If I am ever having trouble remembering, I know that radical 3 over 2 is greater than 1 over 2. And at this point, I go out farther than I go up, so that's how I'm able to know straight away that this is radical 3 over 2, 1/2. And then this one is 1/2 radical 3 over 2 because we're only going between those two values. That's just a quick tip on how to remember which one's which if you are having a little bit of trouble with that. And then pi over 4 is easy. It's just always radical 2 over 2, radical 2 over 2. Okay, so we are only using these three values. So radical 3 over 2, 1/2, and radical 2 over 2. That's going to be important when we're solving trig functions. Okay, so associated with every angle drawn in standard position except for quadrantal angles, there's another angle called the reference angle. And quadrantal means it's on the axes. Okay, the reference angle is always going to be the acute angle. Important piece is acute, formed by the terminal side of the given angle and the x-axis. So our angle is always going to be drawn to the x-axis. Reference angles may appear in all four quadrants, but angles in quadrant 1 are their own reference angles. Okay, so this is just to iterate why we use reference angles, because by using reference angles, you only really need to memorize the first quadrant of the values. Not even for sine and cosine, just you only need to memorize the first quadrant of points, and then if you have that, you're able to recreate the rest of the what's it called? The unit circle. Okay, so I'm going to just draw what these reference angles are going to look like. I just want to remind you all that pi is equal to 180 degrees and 2 pi is 360 degrees. Okay, so I'm always going to have my going to have a standard angle. So I have the vertex of the origin and it's going on the positive x-axis. For quadrant 1, I'll just pick any old angle in quadrant 1. Okay, and so these are the reference angles. Then x is going to be equal to theta. So x is our reference angle. Right, quadrant 2, again, write a standard angle going into the second quadrant. This is theta. Now, if I am looking to find, so the angle I'm trying to find is this one right here. That creates my reference angle in this over here. So you'll probably remember that from the video we watched. So then I am looking for this angle because it reflects over to the other angle. I'm actually going to erase this here just to get rid of any confusion. So then x, my reference angle, is going to be equal to this straight angle here is 180. So if I subtract theta, I'm left with my reference angle. So this is going to be 180 minus theta will give me this angle right here in the blue. Okay, then in quadrant 3, draw my standard. We've got to go around this way. Okay, so that's theta. And if I were to draw right angle there, then that would reflect this over into the first quadrant. So you see that those two angles are the same. So that's why we want that blue angle. Okay, then the formula for that is if I take this whole angle minus this straight angle, I'm going to be left with my triangle there. So x is going to be equal to the angle minus 180 degrees. Then finally in quadrant 4, this goes all the way around, and our reference angle is this angle right here, gets reflected over into here. So what we want to do to find the blue angle is we want to take our entire circle, and then we just want to be left with this little bit. So if we take 360 minus our theta, we'll be left with just our x. Okay? And the reason why we want to know this stuff up here is if we're in degrees, we want to subtract 1. If we want to do the subtract in degrees if we're doing the other. So this would be x equals theta still. This would be x equals pi minus theta. X equals pi minus, or theta minus pi. And this one is x equals 2 pi minus theta. Okay, so we want to find our reference angles for each of these. Okay, so I first have to kind of decide what quadrant are we in. All right, so for this one, we're in quadrant, not 2, we're in quadrant 3. Okay, so if I'm in quadrant 3, I'm going to try and not use these formulas up here because then I'm going to get stuck otherwise if I'm not able to do it otherwise. So if I'm in the third quadrant, that's over here, just going to draw some random angle for visual purposes. I need to get this angle right here, and I'm going all the way around. So what I'm going to do is I'm going to take 360 minus the 345, and that's going to give me 15 degrees as my reference angle. All right, second up, I've got 5 pi over 6. So 5 pi over 6 is so we've got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So 5 pi over 6 is in the second quadrant. So what I'm going to do is I'm going to take this straight angle minus my theta to get my angle. So this is second quadrant. So I want to do pi minus 5 pi over 6 to get my reference angle. Now, pi is the same thing as 6 over 6, or I'm sorry, pi is the same thing as 6 pi over 6, minus 5 pi over 6 is 1 pi over 6. Okay, so now we have a negative angle, so negative 135. That's going to be in the second quadrant. So what I want to do, so here's negative 135, and I want this angle right here. So if instead of subtracting 180, because I'm going the negative way, if I add 180, so if I do negative 135, or subtract negative 180, I should say, then I end up with 45 degrees as that angle. Now that's our reference angle. Okay, go ahead and try these next 3 on your own. Okay, so 580, what you should have said was that, first of all, this one's a little trickier because we have a number that is bigger than 360. So I'm going to get this down and find its coterminal angle. So we get 220 degrees. Now 220 degrees is in the third quadrant. So then if I take 220 degrees minus 180, I'm going to be left with 40 degrees for my reference angle. All right, for 5, we've got 8 pi over 3. Again, this is bigger than pi, so I'm going to find the reference angle, or I'm sorry, I'm going to find the coterminal angle first. So I have 8 pi over 3 minus 2 pi. So I get, so 6 pi over 3, 8 pi over 3. So I get 2 pi over 3 is that coterminal angle. So then to find the reference angle, 2 pi over 3 is the same thing as 4 pi over 6. I change it so it's easy for me to count. So I have 1 pi over 6, 2, 3, 4 pi over 6. So 2 pi over 3 is right here. So it's in the second quadrant. So then if I take 180 minus, or not 180, sorry, pi minus 2 pi over 3, then I get pi over 3 as that reference angle. Okay, so we're going to use reference angles to evaluate our expressions, and we're going to give exact values. Something I want to point out is, again, if we have this is going to be positive, positive. This is negative, or positive, negative, 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 and negative, positive. Okay, so we have this information. We also know that x comma y is equal to cosine of x sine of x. So because of that, I know that in this quadrant, everything, sine, cosine, tangent, cosecant, secant, cotangent, those are all positive. In the second quadrant, sine is positive because of this right here. Sine of x is positive because it's our y value, and our y values are positive.
Mr. Fowler, if you're in the building, would you come to the front office, please?
Next up, we have our third quadrant. Everything's negative, but tangent is sine over cosine, so tangent is positive. And then finally, in our fourth quadrant, cosine is positive. And those, and so because sine is positive, then cosecant is positive. Because tangent is positive, cotangent positive, and because cosine is positive, secant is positive. So as we're going through, we're going to use reference angles, but knowing what quadrant we start in is going to be really important for determining if it's positive or negative once we find that reference angle because of those reflections. So I have 135 degrees. So first, let's just focus on the reference angle. So if I find my reference angle, 135 is in the second quadrant. So I'm going to do 180 minus 135. 180 minus 135 is 45 degrees. In the second quadrant, sine is positive. So I'm looking for a positive sine of 45. That is going to equal the same thing as sine of 135. And sine of 45 versus sine of 135, sine of 45 is easy. I know that anything, so I should know my values in my first quadrant. Those should be, very quick memory. Sine of 135 off the top of my head, I'm not too sure, so that's why I'm going to use the reference angle. So sine of 45 is just radical 2 over 2, and that made the problem a lot easier by doing that. All right, let's look at number 8. So 4 pi over 3, let's find the reference angle. I know that 4 pi over 3 is in the third quadrant because it's greater than pi, but not quite big enough, bigger than 3 pi over 2. So to find my reference angle, I'm going to do 4 pi over 3 minus pi, and so I get pi over 3. Now, in the third quadrant, everything except tangent is negative, so I'm looking for a negative cosine of pi over 3. Cosine of pi over 3 is, I think, radical 3 over 2, but let me check. I'm a little rusty. Pi over 3 is actually 1/2 for cosine. So I'm going to get negative 1/2 for that answer. All right, now we have cotangent of negative pi over 3. Let's first use our what's it called? Identity. So I know that cotangent of negative pi over 3 is the same thing as negative cotangent of pi over 3, and that cotangent of pi over 3 is easy to find. So if we don't quite remember what those values are for cotangent, we can easily find it by saying cotangent is equal to cosine over sine, which we do know. Cosine of pi over 3 is 1/2, and sine is radical 3 over 2. So then we just keep simplifying, so we get 1/2 times 2 over radical 3. So we get 1 over radical 3, but we don't like, I'm changing my direction here. So I get 1 over radical 3. If I multiply by radical 3 over radical 3, I get radical 3 over 3 as my answer. But I have to make it negative, so negative radical 3 over 3 is the value of that. Now, we always want our answer exact. But this is a hint that you can always check your values in your calculator. All right, with that being said, I want you to go ahead and do 10 and 11 on your own.